This is the second section of the Inequalities chapter in Further Pure 1, and here we're going to be looking at using graphs to solve inequalities. Now in the previous section we solved them algebraically. Now if a question asks you to solve it algebraically, you don't use this method. Now how can we solve inequalities graphically? Well, let's just draw some sort of random curve here. Let's call this f of x. Okay, that there, and let's draw like a linear. So let's draw maybe a line that goes like this. Okay, and let's call this g of x. Now there are some portions of this graph where one graph is above the other. So for example here you can see that f of x is above or greater than g of x. I can see on this side of the graph that the graph of g of x is greater than the graph of f of x, and that gives us our inequalities. So if I highlight these different bits, so this part of the graph here, and that would be between whatever these values of x are, so here, one here and one here. So between those two values at the top, I would have g of x, whatever that function is greater than f of x. Now you sort of get the same thing at the bottom, but sort of written the other way around. So let's use a different color. So down here, so let's use the highlighter rather than the pen. So here, okay, this part of the graph between the same two values as above, this is where f of x is less than g of x. Now that's exactly the same as what was written above, that just flipped around. So here f of x is less than g of x. Okay, these two things are the same thing, just written differently. Okay, if we then have a look at the other side, so let's use a different color over here. So here, this bit I'm highlighting in orange here, this is where this graph is greater, or f of x is greater than g of x. So if I put a value, or just put something on the axis here, okay, and maybe we'll label these in a minute. We'll just call them a, b and c. So let's call this a, b, c like this. So at the top what we have is f of x. This is when f of x is greater than g of x. And just like we did before, at the bottom, sort of the same thing, just written the other way around, is this bit down here represents when g of x is less than f of x. Yeah, so it's the same as what was written above, but as I said, just written in a like flipped around the other way around. So if we can find these points of intersection, well, this point of intersection, let's say for example here, okay, and that will give us b. So we would solve simultaneously to find b. So that's the point at which f of x equals g of x, and that's going to be some coordinate where x equals b. I can then write down solutions to these inequalities. So for example, if I was asked to solve when g of x is greater than f of x, I would say, well, that's when between the values of x equals a, or I could write down like this as a set of values, when x is between a and b, those two values that I've labelled up, that I've called a and b, so this one and this one, and then between c and b, or b and c, and actually because these graphs go on forever, I could say from b up to infinity, but I'm just going to be looking at the values I've got here. So I could say that f of x is greater than g of x And on my little sketch here, that will be for the set of values from B to C. Okay, now obviously I would need to consider my inequality signs, and that all depends on the inequality sign that's given in the original question. So it may be greater than or equal to, or less than or equal to, or just greater than or less than. Okay, so that's basically the what we're going to be doing to solve these inequalities, simultaneously sketching them and seeing where one graph lies above another. Now in this section we're going to be sketching some graphs that may not be familiar. So we're going to be looking at sketching, I'll call it new graphs. So I'm not talking about quadratics, or I'm not talking about linear graphs or even cubics, because we know how to do those. So graphs that may look something like this. Here's an example: 4x minus 2 over 5x plus 3. Okay, and the question is going to be, how do we solve a graph like that? Or how do we sketch a graph like that? It looks like some sort of reciprocal graph. Right, so when we do a question like this, these are the steps we're going to follow to sketch them. So the first thing, we need to see if there are any vertical asymptotes. Are there any vertical asymptotes? Okay, and we're going to get vertical asymptotes for values of x which are not allowed in the denominator. So in my example here, for example, well, in all fraction questions like this, you're never going to be allowed 0 in the denominator. So I'd work out 5x minus 3 or plus 3 equals 0, and that will tell me that I'm not allowed an x value of negative 3 over 5, and at that point I will draw a vertical asymptote. So for vertical asymptotes, what we need to do is to find out what value, or it could be values of x, so I'll put that s in brackets, so what value or values of x make 0 in the denominator, because that will make it not defined when we divide by 0. So that's the first thing. Are there any vertical asymptotes? The second thing is, are there any horizontal asymptotes? Now, we won't have drawn any graphs that have horizontal asymptotes up to this point, apart from the graph of 1 over x, or negative 1 over x, or 1 over something. We've not come across graphs where you've got something other than a constant at the top of the fraction. And the way that we find out these y values is to see what the this fraction, this algebraic fraction, tends to as x tends to infinity. So if I were to go back to my example up here, now as in this, as x tends to infinity, what's going to happen is the 4 times a very big number is going to get very big. 5 times a very big number, the bottom is going to be very big. It comes to a point where I ignore these constants. Okay, they're not going to make any difference. So basically, this is going to tend to 4 times a very big number divided by 5 times a very big number, and basically that tends to 4 over 5. So that's where my y asymptote would be. So I would then write y equals 4/5. So the process that we do when we see what the fraction tends to as x tends to infinity, basically what we do is we cross out any constants because basically they're going to be insignificant as x tends to infinity. And then you almost like cancel out the x, or you just cancel it down, because if you're tending to a very big number, you've got the same very big number at the top and the bottom. So in the example here, 4 times something divided by 5 times exactly the same number. So you can almost think of it like 4 times infinity divided by 5 times infinity just cancels down to 4/5. You can think of it like that, but strictly speaking, you know, you wouldn't write 4 times infinity divided by 5 times infinity unless you find that helpful. Yeah, so you could, I suppose, write 4 times infinity over 5 times infinity if you find that helpful, and then cross out the infinities because they cancel out. Yeah, and that will tell you, you know, what it tends to as x tends to infinity. So that will give you any horizontal asymptotes. So we've got vertical asymptotes, we've got horizontal asymptotes. Now, what we need to do after that is we need to see where the graph is. What do I mean by that? So if I were to draw some axes here, let's say I worked out there was an asymptote here and an asymptote over here like this. The graph is going to appear in 2 sections. So it could be that I get part of the graph here and a part of the graph here. Yeah, that's one option. Or I could get a part of the graph up here and a part of the graph down here. Yeah. Or, and this is where you get like something squared in the denominator. So if it was in brackets squared, then the 2 parts of the graph will either be at the top or the 2 parts of the graph would be at the bottom, like this. Yeah. Now, how do we decide which one of these, what I call quadrants, which 2 of the 4 quadrants am I going to find the graph in? And basically, I can just work out where the graph crosses the axis. So use x equals 0 to find your y coordinate, and use y equals 0 to find your x coordinate, to find out where the graph crosses the axis. So where the graph crosses the axis. Now it may be that it crosses at 0, 0. So it's only going to tell you where one bit of the graph is. So what we can do is then maybe plug in some x coordinates either side of the asymptotes, then to work out whereabouts the other part of the graph is. So if necessary, what we can do is use x coordinates either side of asymptote. And once you do that, that will help you work out where in one of these quadrants the graphs occur. So do you get a bit here and a bit here? Do you get a bit here and a bit here? Or do you get a bit here and a bit here, like that? That will only occur when you've got squared in the denominator, or down here or down here. Okay, so that's the process we're going to use to plot these unfamiliar or new graphs. Okay, so it's asking us to, on the same set of axes, sketch the graphs with these curves. This y equals 7x over 3x plus 1, which is the new unfamiliar one, and the y equals 4 minus x, well, that's just a linear, straightforward linear graph. Right, so what we need to do is to see if there are any horizontal and vertical asymptotes. Now, for vertical asymptotes, we want to make sure that we don't get 0 in the denominator, which means that 3x plus 1 cannot equal 0. Now if 3x plus 1 is going to equal 0, that's 3x equals negative 1, or x equals negative a third. Okay, so what that means is when x equals negative a third, we will have a vertical asymptote. Yeah, because we don't want that number in the denominator. Okay, to find if there are any horizontal asymptotes, we look to see what does the fraction tend to as x tends to infinity. So what does 7x over 3x plus 1 tend to? Now, remember what I said, any constants as x tends to infinity are going to be insignificant, so we can cross them out. So we're basically just looking at what 7x over 3x tends to. Now, as I said before, you can sort of cancel this down because x is going to be the same number at the top and the bottom, a very big number. So it means that this fraction, so I'll write it down like this, that 7x over 3x plus 1 tends to 7 over 3 as x tends to infinity. So what that means is we have a horizontal asymptote at y equals 7 over 3. So horizontal asymptote. So now we're ready to put those asymptotes in. So let's do it over here. So x, y, and vertical asymptote at x equals negative a third. So let's put that there, negative a third, and a horizontal one at 7 over 3. Okay, so you've got one there, 7 over 3. Now the next thing we need to do is to work out where the bits of the graph occur, which quadrants of the asymptotes do they occur. So do I have a bit up here and a bit down here, or do I have a bit over here and a bit over here? Okay, that's what I'm going to work out now, and the way that I do that is by working out where the graph crosses the axis. So let's start by making x equal 0. So at, probably shouldn't write it there because that's where I'm going to draw my graph. So at x equals 0, so that's where this graph is going to cross the y-axis, I will have y equals 7 times 0 over 3 times 0 plus 1. Okay, well, we're going to get y equals 0. So this tells me that the graph crosses both the x and the y-axis at 0, 0. So that tells me that the graph crosses this point, so it goes like this. This is the only way it can be drawn, so that it goes through that point. Okay, now my suspicion is the other bit is here. Yeah, but I'm just going to check. And the way I'm going to check is to pick some other coordinate, some other x value. So I'm going to pick an x value, let's say minus 2. So I'm going to put in an x value of minus 2 and see where that takes me. Does it take me to a y coordinate down here, in which case I'll end up with a graph like this, or does it take me to a y coordinate at the top there, which is going to take me to a graph that looks like this? That's what I want to do. Okay, so let's try that. So let's say at x equals minus 2, what do we get? We get y equals 7 times by minus 2. Now I've just chosen minus 2. You could choose minus 1, for example. Some number that's on the left-hand side of the asymptote, that vertical asymptote, and choose a nice easy number. So 3 times by negative 2 plus 1. So what does that give me? It gives me y equals negative 14 over minus 6 plus 1. So that gives me y equals, so it's going to be negative 14 over minus 5, which is just 14 over 5. So that's going to be 2 4/5, I think, which is like 2.8, 2 4/5. Right, that is going to be above this asymptote, so it's going to be up here. So it's going to be some sort of point up here somewhere, which tells me then that the other part of the graph goes like this. Now remember, it's just a sketch. So there's my sketch now of the graph of y equals 7x over 3x plus 1. Now I need to draw a sketch of the line y equals 4 minus x, nice and easy. So this is going to cross, let's make y equal to 0, that means x must equal 4. And then if I make x equal to 0, that means y equals 4. So I've got a straight line, and let's try and get it to cross both. So something like that. Okay, and we'll just label this up. So this is my y equals 4 minus x, and this graph here is my y equals 7x over 3x plus 1. Right, so I can see that this graph crosses, they intercept in two places, so here and here. They're my two intersection points, and then part B is to work out what those values are. Okay, so let's now move on to part B. So this is just solving those equations simultaneously. It's just writing 7x over 3x plus 1 equals 4 minus x. So the next thing I'm going to do is multiply both sides by 3x plus 1. So it's just solving an equation. So I've now got 7x equals 4 minus x times by 3x plus 1. So from there, we'd want to expand the brackets and bring everything on the same side. So let's expand the brackets first. So 12x plus 4 minus 3x squared minus x. Let's bring it all to the same side. So we'll have 3x squared. Then we have 7x. We got 12x minus x. That's 11x. I'm bringing it to the other side. So I'm going to have 7x minus 11x, which will give me negative 4x. So minus 4x, and then bring the 4 to the other side as well. So minus 4 equals 0. This can be factorized. So I have 3x in one bracket, x in the other. So the two numbers can either be 4 and 1 or 2 and 2. I think they're going to be 2 and 2, because that will give me 6x, which I can then take away, or minus 6x, and then plus 2x, so that'll make the minus 4x. So from there, I'll get my solutions as x equals 2 from the second bracket, and from the first bracket, x equals minus 2/3. So these are the x coordinates of the point of intersection. That's all we need. We don't need to find the y coordinates. Okay, we could do, but when we come to write the answer for the next part, part C, we're going to be given the inequality in terms of x only. So we don't need to work out the y coordinates. So since we don't need them, we're not going to work them out. So part C now says that we want to solve this inequality. 7x over 3x plus 1 is less than 4 minus x. Now what this means, it means the less than is like below. So we're looking for the parts of the graph where the reciprocal graph is below the line. So I'm just going to highlight that. So the reciprocal graph, when is it below the line? So it's below it there, and it's below it here. It's below it from negative infinity up to this crossing point, which it must be the minus 2/3. And then it's below it from just greater than this asymptote here, greater than negative the third, up to the other crossing point that must be 2. So I'm just going to mark in those coordinates. So we have 2 here, and this one here, that's going to be minus 2/3. So we've not been asked to give the answer in set notation, so we can just give the answer as x is going to be less than minus 2, sorry, minus 2/3, because that was that green part there, or the other part is where x is greater than that asymptote and it's less than 2. So it's important that we use the right signs as well, because the question was given as less than, not less than or equal to. Or yeah, so x is less than 2, but it's also greater than that asymptote, which is at minus 1/3. So there we go. So that would be our set of solutions here. So just be prepared to give your answer in set notation if they ask. So you should now be able to do exercise 4B on pages 98 to 99. In terms of a recap, I'd probably just refer to that first slide again. Yeah, because that covers everything, but let's just quickly say the first thing that we're going to do is we're going to sketch any graphs. Yeah, if those graphs are unfamiliar, okay, so let's call these ones known graphs that we know. So we know how to plot linear, quadratics, cubic. You should be able to do quartics as well. For any unknown graphs, like we just did, then we need that method of finding horizontal asymptotes, vertical asymptotes. Don't need to write the word vertical since I've already drawn a line to indicate it's vertical. So vertical asymptotes like this. And we also want to find any points where it crosses the axis, crosses coordinate axis. And if it crosses at 0, 0, then like you might want to also, well, you will have to use points either side of the asymptotes that you've got. So pick x values either side of those asymptotes and see which part, which section of where the asymptotes are, the graph is going to be. Once we've sketched the graphs, then we want to find the points of intersection. And then once we've got the point of intersection, we can solve the inequality. Solve inequality. And basically remember that if we have this symbol, it means where one bar graph is above the other. And where we have this symbol, it's where the other graph is below the other. Okay, now sometimes it may include this equal to as well. That doesn't change any of the working, it just changes your solution. You just need to make sure in your solution you have the greater than or equal to or less than or equal to inequality sign in your solution.